So for this Excel tutorial, I'm going to go over chi-squared test. Okay, and this is a statistical test that you would use when you're looking at frequencies. Okay, so when you put a number of individuals in a particular category. Okay, so what is this test for? What does it tell you? This test compares measurements relating to the frequency of individuals in defined categories. The number of white and purple flowers in a population of pea plants, for example. Okay. Chi-squared is used to test if the observed frequency fits the frequency you expected or predicted. Okay. So how do we calculate the expected frequency? A good way to do this is, or a good example of this, should I say, is in genetics when you're using Punnett squares. Okay. So you might expect an observed frequency of your data to match a specific ratio. For instance, 3:1. Ratio of phenotypes in a genetic cross, Punnett square, things like that. Or you may predict a homogeneous distribution of individuals in an environment. For instance, the number of daisies counted in quadrats on a field. Please note, in some cases, you might expect the observed frequencies to match the expected. In others, you might hope for a difference between them. It entirely depends on your hypothesis, or at least your theory, what you're trying to find out, okay, what you expect to happen. So as I said, a good way to show you an example is genetics. Okay, so what I'm going to do is I'm going to show you how to create a Excel spreadsheet to give you a chi-squared value. Okay, this means that when it's all set up and nicely set up, you can save it and hopefully use it for data that you might have, or data that you might collect in your investigation. Okay. So in this instance, we are comparing the observed frequency of different maize grains with the expected ratio calculated using a Punnett square. Okay. So in this photo, it shows 4 different types of phenotypes for maize grains. And this is as follows. Category A, is known as purple and smooth. Category B is purple and shrunken. Category C is yellow and smooth. Category D is yellow and shrunken. So the Punnett square below shows the expected ratio of phenotypes from crosses of 4 genotypes of maize. Okay. So got purple and smooth, purple shrunken. Okay. So we've made a ratio that for every one of category D we find, okay, for every one of category D we expect 3 of category C, 3 of category B, and 9 of category A. Okay, so in this case, what is the null hypothesis? H0, HO, the null hypothesis. There is no statistically significant difference between the observed frequency of maize grains and the expected frequency of 9 to 3 to 3 to 1. Okay. Now when we calculate chi-squared, we need to look at a critical value. If chi-squared exceeds that critical value, we reject the null hypothesis. By rejecting the null hypothesis, we will have to accept HA. HA means there is a significant difference between the observed frequency of maize grains and the expected frequency. Okay. So to calculate chi-squared, you need to use this equation. Okay, it's very simple compared to the other ones that you may have seen during these tutorials. Okay. Now, I've gone ahead and I have collected some data. Okay. And this is my observed data. Okay. Now we need to calculate what we expect. So I'm just going to copy this over into Excel. Okay, so that's the phenotype. Observed, expected, observed minus expected, squared. Okay. We have A, B, C, and D. So 217, 271, sorry, 73, 63, 26. Okay. So I want to insert this strange looking E. This strange looking E is the Greek capital letter sigma. Okay, and that just literally means the sum of, the total. Okay. If you cannot find this, if you're trying to scroll through and you can't find it, take note of this character code. This character code is unique to this symbol. So if you copy 0, 3, A3 and type it in there, it will automatically come up with sigma. So if you insert and close, okay, now we need to add these numbers up. So I'm going to type in equals sum, open the bracket. I'm going to select all of those and close the bracket. And this will give us the total number of maize grains that I have observed, which is 433. Now we need to calculate our expected. So we have a ratio, which is 9 to 3 to 3 to 1. Yeah? So the sum of that ratio, so as in 9 plus 3 plus 3 plus 1, should be 16, which is. So what you're going to need to do to figure out your expected, you're going to press equals. You're going to open the bracket. You're going to take 433 and divide it by 16. Close the bracket. And then you're going to times by 9, or times by the respective ratio that you would expect. So for A it's 9. Okay. Before you press enter, put $signs in front of the B and in front of the number, or A and then the number. Okay. What this does is it tells that cell, or tells the formula, not to move from that cell. Okay. You're going to press enter. Okay. Now you're going to click. You're going to drag down. Now, it does come up with zeros, and that's because you need to change these numbers. So instead of B10, you're going to need to select C9. Yes, that's 3. Enter. It is up to you. You can just type in the same formula without the dollar signs. Okay. Or you can do it that way. It's up to you. Okay, equals sum. These need to be the same. Equals, yep, 433. So just by looking at this data, already we can see that there is some significant difference. But for chi-squared, essentially what we're trying to do is we're trying to find if it definitely is different. Because it's alright just looking at them and saying, yeah, okay, they're different. But is it significant? That's the question you need to be asking. Okay. So, observed minus expected. Observe minus expected. Enter. I'm going to click back on the cell. And because the formula is going to be repeated, I'm going to highlight this little square in the corner of the rectangle. It will turn the cross black. You're going to click and you're going to drag. There you go. And yes, it will be minus numbers, do not worry. Now this one, you need to square the last box. Okay. Again, it's going to be the same formula, so you can click and drag. Now this one equals that box. And all we've done is we've just divided by the expected. Okay. Again, you can click and drag. Now, we need the sum of these. So equals sum. Open the bracket. Select all of those numbers and close the bracket. That number is your chi-squared. I'm going to highlight that. That is chi-squared. That is your chi-squared value. Okay. So now, what do we do with that number? It's an old one, so it is wrong. Right. So now we've calculated chi-squared. We need to compare our calculated value of chi-squared with the critical value in stats table. Okay. So if this is our value, we need to look at we need to figure out how many degrees of freedom we've got. So in this instance, the degree of freedom is the number of categories minus 1. So 4 minus 1 is 3. Okay. The probability that we are correct, the probability that we're trying to find, is 0.05. So P equals 0.05. Okay. Looking on one of the statistical table, when the degrees of freedom is 3 and the probability is 0.05, the critical value is 7.82. Okay. Is our value higher than the critical? Or is it lower than the critical? Our value is higher. Therefore, we can reject the null hypothesis. Okay. By rejecting the null hypothesis, we are saying that there is a significant difference between our expected and the observed ratio. For instance, they are a poor fit. Now, why might that be? It could be down to a number of things. However, the main ones, especially as a scientist, we would say that our sample size was too low. So, in order to improve results, we need to take a bigger sample size. Number 2, it could be down to random error. Notice that I'm saying random, not human. Okay. Random error because of how I may have, or in your team you might have, discussed what category that particular maize grain may fit into. For instance, where's that picture? So, for instance, is it wrinkly? Is it definitely wrinkly? Is it smooth? Is it definitely smooth? As you can see, some of these are very, very smooth, but others do have a slight wrinkle. Yeah, you can see that these are overly wrinkled. But what about this one? That one? That one? Is it purple or is it brown? Do we need extra categories? And these are all questions that you need to be aware of. Okay. Another reason why, and one of the reasons that most definitely will influence the Punnett squares and our observed and the expected, is due to, what's the word I'm looking for? Due to genetic mutation. Okay, so the genes have mutated to fit the environment, which is something that we've not taken into consideration. Okay, so because of that, it could be different. Could be in the keyword. We won't know until you do it. Right? So that is it. That's all I've got. This is now your working sorry, I'm going to cough. This is now your working Excel spreadsheet for chi-squared. By changing the observed or the expected, or even the ratio, by changing the ratio, it will change your answer. So you won't need to do all of this again. So please ensure that you save it so then you can use it on the next question. If you're using my Neopod, there is another question, you will need to use it for that. Okay, thank you. See you in the next one.